Okay, so this is the second to the last week of classes. We're going to take up this week power in AC circuits. And then next week, we're going to take up transformers. Pagkatapos nun, tapos na yung triple E 1, 2, 3. So panibagong topic to. I hope you mastered adequately the phasor method, because this will rely on the knowledge that you got when the phasor method was discussed last week. Okay, let us first investigate what happens when an AC current is made to pass through the different passive elements. So we'll start with a resistor. So consider a resistor, this resistor, and let's assume that you have an AC current that is passing through the resistor. Of course, you're going to generate a voltage across that resistor. And that voltage, based on Ohm's law, V is equal to Ri, will be equal to R times this expression. So ito lang yan, ano? That's Rim cosine omega t plus theta I, no? Theta I is the phase angle of your current. Okay, what will be the instantaneous power delivered to the resistor? Ano yung formula natin for power? No? Our formula for power, P is equal to VI, if you recall. So P is equal to V times I. So I multiply the voltage by the current. No? And that's what I do here. No? Pag minultiply ko yung IR at saka VR, I'm going to get R, Im squared, cosine squared, omega t plus theta I. Now you have this trigonometric identity. I don't know if you remember it, but you have this trigonometric identity. Cosine squared of theta is equal to 1/2 of cosine to theta. That's a trigonometric identity. In other words, itong cosine squared omega t plus theta I na to, sorry, mali. Erase. Sorry. Cosine squared of theta is equal to, 1 plus cosine 2 theta over 2. No? That's the identity I was looking for. No? So itong cosine squared omega t, I can convert that to 1 plus cosine 2 omega t plus theta I. No? And then if I convert I to RMS value, if you recall, I of m is equal to I, that is the RMS value, times the square root of 2. That is, if I is the RMS value of I of r, okay, the value of I is I of m over the square root of 2. So if I convert it to RMS value, ito yung lalabas. So this is my final expression for P of r. Nasundan mo ba? Are you following, Albert?
Yes, pa, yes.
Okay, just give me a thumbs up now if you're following, or if you can, or just give me a thumbs down na lang if you cannot follow, no, so that we can I can slow down or I can expound further. Okay, so ito yung lalabas na expression natin for P of r. Again, this is the instantaneous power that is delivered to a resistor. Kung ipa-plot ko to, no, let me plot this. Ito yung lalabas na plot. You notice that here you have two components, no? I can split this into two components. This is equal to I squared r plus I squared r cosine 2 omega t plus theta I. No? So this is a constant. No? Ito constant. And then this is a sinusoid. So itong constant na to, ito yon. Okay. And then on top of this, we add a sinusoid. We add this sinusoid. ang magiging maximum value ng instantaneous power natin would be 2I squared times R. No? Kasi ang maximum value nitong cosine function is equal to 1. So when this cosine function is equal to 1, ang maximum value ng instantaneous power natin would just be 2I squared times R. So if you take a look at the instantaneous power delivered to a resistor, you have an average value. No? This is your average value. But if you take a look at the actual waveform, okay, pag minsan mataas yung dinideliver na power, pag minsan bumababa yung dinideliver na power to 0. And this is in a sinusoidal fashion. That's because this is a sinusoidal term. No? So sinusoidal function. Tapos yung isang observation is, pag tinignan natin yung frequency ng power would be twice the frequency of my current. So ang frequency ng current ko, ang angular frequency is omega. No? This is my angular frequency. Okay. The frequency of my power would be 2 omega. That's why the period would be omega over pi over omega. No? Because dapat yung period 2 pi over omega. Normally, the period would be 2 pi over omega. But then, nagdodoble yung frequency. So yung period ko would be pi over omega. So this is the power that is delivered to a resistor if you make an AC current flow through it. So I just want you to get a feel for that. Okay, tignan naman natin yung inductor. Okay, so same situation, meron akong inductor. Sabihin natin magpapadaan ako ng current na AC dito sa inductor na to, no? That current I am cosine omega t plus theta I. A voltage will develop across my inductor. And according to my inductor formula, what is V sub L? V sub L is equal to L di dt. No? The voltage across your inductor is L multiplied by the rate of change of your current across your inductor. So if I get the derivative of cosine omega t plus theta I, that's minus omega sine omega t plus theta I. So ito yung magiging expression ko ng V sub L. Again, I want the power, I want the instantaneous power delivered to my inductor. So anong gagawin ko? I multiply again, no? V sub L with I sub L. This is to get power, no? Because again, power is equal to VI. So I multiply this by this. Ito ngayon yung lalabas. Okay? Ito ngayon yung lalabas. Okay? And then again, I can replace this by this, no? Sine to omega t plus theta I, no? Because you have the identity sine theta cosine theta is equal to 1/2 sine 2 theta. Okay? Somewhere in your lifetime, you must have studied this identity. So ito yung magiging simplification niya. And again, if I use the RMS value of I sub L, so again, I is I sub m divided by the square root of 2. So if I use I sub m I equal to, yeah, if I replace I sub m by I times the square root of 2, then you square that cancels with the 1/2. Ito yung matitira. So this is my expression for the instantaneous power that is delivered to this inductance. Okay, let me plot this again. Ano? So again, negative I squared, by the way, no? Recall that omega L is equal to XL. No? You remember, this is the reactance. The reactance of an inductor is equal to the magnitude of its impedance. No? The reactance of an inductor is the magnitude of its impedance. The impedance is j omega L. Ang magnitude nito is just omega L or XL. So this is expressed in terms of reactance. So again, no, let me plot this. Ipa-plot ko to, no? So this is a negative sine wave with a phase shift, no? So ito, naging negative sine wave siya na may phase shift theta of I, no? Actually 2 thetas of I kasi multiplied by 2, no? Okay? Ito yung amplitude ng sine wave, I squared XL. Okay? So ang minimum value niya is minus I squared XL. Ang maximum value niya is I squared XL. And the frequency again is twice the original frequency of our current. So yung frequency ng current natin, kung F yung frequency ng current natin, ang frequency nito would be 2F. Okay. Some observations here. Tanungin kita, Albert, ano? What is the average power delivered to the inductor?
Zero po.
Yeah, that's right, no? Because this is a sine wave. The average of a sine wave, pag kinuha mo yung average ng sine wave, it is 0. So those are the average power delivered is equal to 0. So pag minsan, positive yung power. Pag positive yung power, that means the current is transferring power into the inductance. No? Pag minsan, negative naman yung power, that means the inductance is giving back that power. No? So you have instances where your power is positive, that means you're delivering current to the inductor. And there are instances where your power is negative, that is your inductor is giving back that current. So this is aligned with the inductor being able to store energy. Remember, no? An inductor can store energy. So dito sa positive power, it stores energy, and then dito sa negative power, it gives back that energy. But on average, the power on average that is delivered to your inductor is equal to 0. Okay, isa na lang natitira, capacitor. No? So same situation, we have a capacitor. Let's let an AC current flow through it. Okay, so that is voltage will develop across the capacitor, and according to the capacitor equation, that voltage is going to be 1 over C, the integral of I sub C dt. Because if you recall, I sub C is equal to C dV dt, no? So pag sinolve natin for V, it's 1 over C the integral of I dt. So if I get the integral of a cosine function, the integral of my cosine function is equal to my sine function, I have to divide it by omega, and then I have my 1 over C here. Of course, you have your current amplitude, I sub m. So ito yung magiging expression ng V sub C ko. I sub m over omega C sine omega t plus theta I. So anong gagawin natin ulit? Kukunin natin yung instantaneous power. Multiply V sub C by I sub C. So I multiply this by this, no? By this. And I'm going to get this expression. Again, sine omega t plus theta I cosine omega t plus theta I is sine 2 omega t plus theta I over 2. So that simplifies to this. And finally, if we express I sub m in terms of the RMS value of I sub C, and if we also recognize that x of C is equal to 1 over omega C, x of C is the magnitude of the impedance of your capacitor. Okay. In general, your reactance is the magnitude of the complex component of your impedance. But the capacitor is purely complex. So it's the magnitude of the impedance of your capacitor. So ito yung magiging expression natin ngayon for P sub C. Okay, this time it's just a sine wave, no? Hindi negative. Kaya pag pinlat natin to, of course, meron siyang phase shift. 2 multiplied by theta I is your phase shift. So ito yung magiging plot niya. Okay. So you have your sine wave whose frequency is twice the frequency of my current. And ang maximum value now is I squared x of c. Minimum value is minus I squared x of c. Again, no, the average power delivered to C is equal to 0. Okay. So in summary, no, in summary, kung meron kang AC current na dumadaan sa resistor, doon lang may average power na nade-deliver. That's the only time there is an average power delivered. And that average power, so let's go back to, balik tayo dito sa resistor, no? That average power is equal to I squared times R, where I is the RMS value of my current. Okay. Kapag inductance, ang average power ko 0. Okay. So sometimes power is delivered, sometimes power is received, but the average is equal to 0. Ganon din yung capacitance. My average power is 0. Sometimes power is delivered, sometimes power will be received. Okay. Any questions so far, Albert? Okay pa? Okay, thanks. Okay, let's consider in general, ano? In general. So, assume that this is a passive network. So that passive network is composed of resistances, inductances, and capacitances. If I apply a sinusoidal voltage, I expect a sinusoidal current to flow. No? If I represent this by its phasor, this will also be a phasor. Pero let's think in time domain for the meantime. So if I apply sinusoidal voltage, I expect a sinusoidal current to flow. No? So yung V's of t and I's of t will be of this form, no? This form. So V's of t will be an amplitude, V's of m, cosine omega t plus a certain phase angle. No? And I's of t will be an amplitude, I's of m, cosine omega t plus also a certain phase angle. So this is the phase angle. Theta v is the phase angle of my voltage. Theta I is the phase angle of my current. No? By the way, this is just as a review. If this was a phasor, V is equal to V's of m over the square root of 2 at an angle theta v. No? And this is I is equal to I's of m over the square root of 2 at an angle theta I. Okay. So there's going to be a difference in the phase angle of the voltage and the phase angle of the current. I want the instantaneous power delivered by the voltage source to the passive network. So ano yung instantaneous power that this delivers to this particular network? All I have to do is multiply my voltage by my current. So pag ginawa ko yung multiplication na yon, ito yung lalabas na product ko. So this is just my voltage, and then this is just my current. Okay, just so that you can visualize it, no? So ito yung top graph, ito yung voltage ko. Yung voltage ko, average value niya is 0, right? Because it's a sinusoid. Its amplitude is V's of m, no? Ito yung current ko, this is my current. The average value of my current is also 0 because it's a sinusoid. The amplitude is I of m. And my frequency, no, is equal to omega over 2 pi. That's frequency in hertz, no? In hertz. No? Because if you recall, omega is equal to 2 pi times f. No? So my period t is equal to 1 over f. And so this is going to be my period, the period for my voltage and the period for my current will be the same because the frequency of my voltage is the same as the frequency of my current. Okay, what will happen if I multiply this blue curve with this red curve? No? So this is just to visualize. Ano mangyayari kung yung blue curve, yung voltage, i-multiply ko ng red curve, which is current. No? Of course, I'm going to get the plot of my instantaneous power. Okay, so whenever my voltage is 0, my power is 0. No? Whenever my current is 0, my power is also 0. No? Now, in this particular interval, my voltage is negative, my current is positive. Negative times positive is negative. No? Now, dito sa interval na to, my voltage and current are both positive, kaya my power is positive. Dito sa interval na to, my voltage is negative, my current is negative, my power is positive. So anyway, this is what your plot will look like. Actually, I just generated this plot using Excel. No? Nag-feed in lang ako ng dalawang sinusoid sa Excel, and then I told Excel to multiply the two, and it generated this plot for me. Of course, you could have used MATLAB or whatever other Octave or whatever other tool you already know how to use. So this is my instantaneous power. Okay, note that the phase angle between my current and my voltage is this, because okay, this is the point where my voltage is 0. This is the point where my current is 0, coming from being positive, no? So this is my voltage is 0 coming from being positive. This is my current is 0 coming from being positive. So this is my angle between my voltage and current. So theta V minus theta I. Okay, what can we observe about this power, this instantaneous power? So note it is sinusoidal. Okay. The frequency, so dito nakita natin dito, the frequency is twice the frequency of either the voltage or the current. Okay. There are times when power is being delivered. So ito, no? Here you see positive power dito, positive power. And there are times when power is being received. No? So we're talking about the source, no? Kasi ito yung scenario natin, di ba? May source, meron tayong source. So there are times when the source is delivering power, and there are times when the source is actually receiving power. So kailan siya nagde-deliver? Dito nagde-deliver siya pag positive yung P. Dito tumatanggap siya, no? Pag negative yung P, no? Ito. Tumatanggap siya dito pag negative yung P. Dito nagde-deliver yung source pag positive yung P. Okay, mapapansin mo that in general the average power is not equal to 0. So meron tayong average value. So that is the general case. When you have a network consisting of resistance, inductance, and capacitance, and you have a source supplying a current of a voltage to this network, you're going to generate a sinusoidal current. You multiply the voltage and the current, you get the instantaneous power. The average of that is not, in general, is not going to be equal to 0. Any questions so far? Albert, are you still there? Okay, thank you. Okay. Okay, so balik tayo dito sa expression na to, no? Expression ng P. So I have here an expression for P, no? This expression. I write it again here. Okay. Sorry, no. I didn't write it again, no. Ang gusto kong sabihin is this, no. Itong expression na to, if I apply mga trigonometric identities, I can express that in this manner. It might enter your head. Parang mas simple kanina yung expression ko kaysa ngayon, ano? Kasi kanina I just did I only had 2 terms, ano? All of a sudden now I have so many terms. But I have an ulterior motive for expressing it in this manner, no? And you're going to see that shortly. So anyway, so this expression for piece of t, I can derive from this expression. I'm not going to show you that derivation, no? In sa triple E 1 2 3 dati pinapakita namin yung derivation na yan, no? Pero ang experience ko, after showing the derivation, the students don't remember it anyway, no? So just maniwala ka na lang, no, na pag manipulate ko yung equation kanina, ito yung lalabas. And you can find that that derivation in textbooks. If you're interested, I can also supply you some notes, no, if you're interested in that derivation. So this is my expression for P. And then if I convert to RMS value, so I convert, instead of V sub m, I use VRMS, no, which is V sub m over the square root of 2, and I use IRMS, which is I sub m over the square root of 2. So assuming that V and I are my RMS values, ito yung lalabas na equation. Okay. Notice that we have 3 terms here, no? So this is a constant. This is a constant. This is also a constant. That constant meaning it does not change with time. So here I have 2 sinusoid. Here, this will result in a constant term. No, this is a constant term. And then this is a sinusoid. And then this is another sinusoid. Okay. So I have a constant term, and then I have 2 sinusoidal components. I have a constant term and I have 2 sinusoidal components, no? In other words, no, ano yung kalalabasan ng P ko, no? My P will be let me call it K1, okay, plus K1 cosine 2 omega t plus theta I, no? That's this term, no? So sabihin natin this is K1, this is K2, and then plus or minus K2 sine 2 omega t plus theta I, no? So I have a constant term, ito yung K1. I have a sinusoid, K1 cosine 2 omega t plus theta I, that is because of this. And then I have another constant term, which is K2 sine 2 omega t plus theta I, which is because of this. Okay. Comparing piece of R to the general expression for P, so ito dinerive natin to kanina, no? We derived this earlier. Just to show you where we derived that is here, no? Ito, right? So this is where we derived this, no? When we got the expression for the when we got the expression for the power delivered to a resistor by a current, we derived our expression for piece of R, no? So again, let me go back to saan na ba tayo? Yeah, so we were here, no? Okay. So this is my expression for piece of R. This is my expression for P that I just derived, that I presented here in the previous slide, no? Ito yun, no? So let's compare these two, no? Compare. Okay. If I compare these two, okay, unang-una, we see that this and this are the same term, ano? So ito magkapareho. These are the same. Okay. So what does that mean, ano? That means that since wala nang ibang term dito, ang ibig sabihin niyan, this must be equal to 0. This must be equal to 0. And what this also means is this I squared R must be equal to VI cosine theta V minus theta I. No? So ibig sabihin ito and this one must be equal. Okay? So that is this. Ano? Yung I squared R must be VI cosine theta V minus theta I. And then itong term na to is equal to 0. If this is equal to 0, ibig sabihin itong constant na to must be equal to 0. Okay. Now what about piece of L? No? So again, no, let's compare piece of L to my general expression here. So ito dinerive na natin to kanina. No? This is the current. This is the power, instantaneous power delivered to your inductance. So this is my general expression for P in a general network. Again, no, I compare these two. You compare. You will notice that the only term we have here is itong sine 2 omega t plus theta I. No? So ano ibig sabihin niyan? Ibig sabihin niyan, itong buong to equal to 0. This is equal to 0. And this will only be equal to 0 if this VI cosine theta V minus theta I is equal to 0. So yun yung sinasabi natin dito. VI cosine theta V minus theta I must be equal to 0. And then this term must be equal to this term. No? Dapat magkapareho to. No? That's why we say I squared XL must be VI sine theta V minus theta I. Okay, pangatlong component, no? Power delivered to a capacitor. So this time, it's I squared XC sine 2 omega t plus theta I, no? Dito it's negative, no? Negative I squared XL. Dito it's I squared XC. So again, you compare. So this is similar to the inductance. This must be equal to 0. Dahil wala tayong term na ganito sa piece of C. And then itong I squared XC must be equal to negative VI sine theta V minus theta I. Okay, let me just summarize what we observed. No? So in general, this is my expression for piece of T, which looks kind of complicated. So this consists of 3 sinusoids. This is my, two sinusoids and 1 constant term. No? This is my constant term. This is my first sinusoid. Of course, amplitude is this. And then this is my second sinusoid. No? Here, V and I are the RMS values of the voltage and current respectively. Okay. For a resistor, this is my expression for piece of R. For an inductance, this is my expression for piece of L. And for capacitance, this is my expression for piece of C. So resistors account for the first term of piece of T. No? So this, itong term na to, rather, this term, this is for resistor, no? Resistors. Okay. And then this one, this is inductors and capacitors. The second term accounts for inductors and capacitors. And yung net power or average power can only be delivered to a resistor. Because it is only in the first term that our average is not equal to 0. Meron tayong average na VI cosine theta V minus theta I. Dito, the average value of my second term is always equal to 0. So there is no net power delivered to inductances and capacitances. Okay, let me now do a series of definitions. Unang i-define natin is real power or active power. Real power or active power is defined as the average value of the instantaneous power. The average value of the instantaneous power. It is the power that is converted to useful work or to heat. Again, I'm going to go back to sana yung graph na yun. I'm going to go back to this graph. Okay, so this is my instantaneous power. What is the average value of my instantaneous power? The average value of my instantaneous power is this. Ito yung tinatawag natin real power. This is our real power, the average value of my instantaneous power. Sorry. Okay? So, yun lang yung pwedeng magtrabaho para sa atin. That is the only power that is capable of doing work for us. Our real or active power. So if you recall again our power expression, okay, since the average value of your sinusoids are 0, then the real power or your average power is just this term, no? VI cosine theta V minus theta I. Now note, we use capital letter P for real power. So that's VI cosine theta V minus theta I. Theta V minus theta I is the phase difference between your voltage and your current. Again, if we recall our expressions for the instantaneous power to a resistance, to an inductance, to a capacitance, okay, the real or active power delivered to a resistor is I squared R. Because this term here corresponds to this term here. No? Itong term na to. So the real power delivered to a resistor is I squared R. There is no real power delivered to an inductance and to a capacitance. In other words, theoretically, a capacitor and an inductor is not capable of doing work. It's only your resistor that's capable of doing work, theoretically. Okay, we're talking about the passive component. Reactive power. Okay, the definition of this is a little bit esoteric, no? The instantaneous power delivered by an AC source to an inductor or capacitor is your reactive power. No? No, sorry. That's not your reactive power. So this is the instantaneous power delivered to your inductance or your capacitance. Your reactive power is the coefficient of this sine term, no? Of this sine term. That is your reactive power. So this is your reactive power for your inductance, and this is your reactive power for your capacitance. So the definition is the negative of the coefficient of the sine term, this sine term. Kunin natin yung coefficient, kunin natin yung negative nun. This is in the piece of the expression, is defined as your reactive power. And the symbol for your reactive power is Q. So this is the power associated with inductors and capacitors. So for an inductance, Q's of L, again, this is the negative, no, of the coefficient. So Q's of L is I squared XL, and Q's of C is negative I squared XC. In general, your reactive power is VI sine theta V minus theta I. This is in general. No? This is for a general network. Again, that comes from this expression. So this is your power attributed to inductances and capacitances. Okay, the coefficient of that is VI sine theta V minus theta I. So this is the negative of this is your reactive power. The negative of this term. So in general, your reactive power is VI sine theta V minus theta I. And the unit for reactive power is VARS. The unit for reactive power is VARS. VARS stands for volt amperes reactive. Okay, so meron tayong dalawang klaseng power. Meron tayong tinatawag na real power real power or active power. And meron tayong tinatawag na reactive power. Okay? Yung reactive power is not capable of doing work. Yung real power is the one that is capable of doing work. Meron tayong tinatawag na apparent power. Your apparent power. The apparent power is just the product of your RMS voltage and your RMS current. This is for a particular component. No? So if I have a component, no, can be a source, can be a passive element. If this is my phasor current and this is my phasor voltage, okay, S is just the magnitude of my phasor current multiplied by the magnitude of my phasor voltage, no? Which is the RMS value of I times the RMS value of V. So that is just S. And the unit for S is volt amperes. Volt amperes. Okay. Now, if you take a look at your electrical equipment, sometimes the rating of your electrical equipment is expressed in watts or real power. Sometimes it's expressed in volt amperes. Madalas to nangyayari, for example, bibili ka ng transformer, no? Titignan mo yung nameplate rating ng transformer. So you buy a transformer, you take a look at it has you call it a nameplate, no? Usually. Doon mo makikita yung specifications ng transformer. Pag minsan sasabihin doon sa nameplate, okay, this transformer is, let's say, 1,000 watts. Okay. Pag minsan ang nakalagay naman doon sa nameplate, this transformer is 1,000 volt amperes. Kung hindi ka electrical engineer, you tend to think that they are the same thing. I've encountered many people, engineers in other fields, for example, mga mechanical engineers, pag nakita nila yung volt amperes, nakita nila yung watts, they think it's the same thing. No? But actually, there's a difference. Pag watts, that is real power. Pag volt amperes, that is apparent power. Okay, note that apparent power is neither a phasor nor is it a complex number. It is just a scalar quantity because it's the product of two RMS quantities. No? Your RMS values are not complex numbers. They are just scalar quantities. So your apparent power is neither a phasor nor is it a complex number. Okay, power factor. Okay, so the ratio of real power to apparent power is defined as your power factor. So P is my real power, and this is VI. Remember that P is equal to VI cosine theta V minus theta I. And then S, my apparent power is just equal to VI. Okay, so P over S will give me cosine theta V minus theta I. This is what you call your power factor. This is your power factor. Now, your power factor must be specified as lagging or leading. So again, when you take a look at equipment rating, okay, sasabihin doon ano yung power factor. Okay, this will give you an idea of the phase angle between your voltage and current when you use that particular type of equipment, and it will be specified there lead or lag. Ano yung ibig sabihin ng lead or lag? The power factor is lagging when the current lags the voltage. Okay, when the current lags the voltage, that means theta I is theta I is negative with respect to theta V. And the power factor is leading when the current leads the voltage. Okay. When the current leads the voltage, theta I is greater than thetas of V. So when your power factor is lagging, then your reactive power is positive. Kasi when does this happen? No? This happens when you have inductive circuits. Okay. You remember pag inductive circuits, yung current lags the voltage. And when you have an inductor, then your Q, so here Q is positive. Ito naman, this is for capacitive circuits. In capacitive circuits, your current leads the voltage. Pag tinignan mo yung tawag dito, yung phasor diagram, laging nauna yung current kaysa sa voltage, ano? Nauna yung current sa voltage. And here, your Q is negative. Okay, so just to summarize, so this is in essence a summary of what I've discussed this afternoon. This is your real power. No? This is your general expression for real power. In other words, if general expression, ibig sabihin ng general expression, if I have a network here, an element, a circuit, whatever, okay, and then this is my I, and then this is my V. Okay. If I get VI cosine theta V minus theta I, so these are the magnitudes of my phasors, no, or the RMS value of my voltage and current. This is my phase angle between my voltage and current. If I get VI cosine theta V minus theta I, that is the real power that is delivered to this particular element. And we know that for a resistor, that is I squared R. No? For an inductance, that is 0, and for a capacitance, that is 0. Because the inductance and capacitance does not absorb or consume any real power. Okay, ito naman, my reactive power is VI sine theta V minus theta R. This is vars. For an inductance, that is I squared X of L. For a capacitance, it's minus I squared X of C. That's my reactive power. My apparent power is just the product of my RMS voltage and my RMS current. My power factor is just the ratio of P over S, which is cosine theta B minus theta I, and you have to specify whether it is leading or lagging. And all of these quantities here, all of this, are not complex numbers. And they are not phasors. They are just ordinary real scalar quantities. Not complex numbers, not phasors. Okay, I want to introduce to you the power triangle. The power triangle is a right triangle whose sides correspond to the real and reactive power. So this is my power triangle. Okay. Theta is the phase angle between my voltage and current. So theta is theta V minus theta I. If this is my real power and this is my reactive power, okay, it's easy to see that P over S is cosine theta V minus theta I. No? That's the definition of the cosine function. No? Because S cosine theta is equal to P. So P over S is cosine theta V minus theta I. And Q over S is sine theta V minus theta I. No? And S, in this particular case, is just the square root of P squared plus Q squared. No? So that's shown here. S is the square root of P squared plus Q squared. No? When you have sine squared plus cosine squared, that's equal to 1. So ang natitira is just V times I. Okay. So if voltage and current were expressed in phasor form, ito yon, no? This is the RMS value of V, this is the RMS value of I. No? Okay, what's nice about the power triangle? No? Given any two quantities, all other quantities can be determined. So essentially, I have four quantities here. No? P, Q, theta, and S. If I know P and Q, I can get theta and S. If I know P and S, I can get theta and Q. No? If I know S and theta, I can get P and Q. So given any two quantities, all other quantities can be determined. And if you remember this, no, there's really no need to memorize these formulas. No? You just have to remember this triangle. But you have to remember also that Q is negative for leading power factor and positive for lagging. No? Kasi dito hindi lumalabas yung sign ng Q. No? Here we just assume that Q is always positive. But if the power factor, that is cosine theta, is said to be leading, then you have to make Q negative. Okay? If it is lagging, then Q can remain positive. So, gamitin niyo yung triangle na to, pero pag sinabi yung power factor is negative, then i-convert mo pa to a negative value. Okay? So, I'll stop there first. No? Meron pa akong mga gustong i-discuss. Yeah, I'll stop there first.